Hello everyone. In this video we will visit adekoCAM operations and tool assignments. We will do this on a model which only has a single rectangle in addition to its part shape, the Antique 4 model. You see the model on the right and the layers the model have on the left. Apart from the sizing layer panel, there is only one more layer, and on this layer is one single rectangle. I disabled the sizing layer and enabled the layer on which the rectangle sits. We will apply adekoCAM operations on this rectangle and see what exactly they do. Let's start with drill. I select operation drill and assign a tool via tool 35mm end mill, telling adekoCAM to get the depth information from the model. This operation finds the center of the geometric feature and creates a hole with a given depth. Not all the operations are supposed to be meaningful for any geometry, and assigning drill to a rectangle is a good example to that. But nevertheless, we will do it to see what happens. As you see, we now have a hole made with the selected tool at the center of the geometric feature. You might want to override the depth coming from the design and change it to 10mm instead. Unchecking the depth from the entity checkbox, entering the overriding value and recalculating. Hole is deeper now because it was 5mm in the design. Continuing with the groove operation, I'm selecting operation groove and assigning a tool. This operation moves the tool over the lines forming the geometric feature. Available options are center, meaning over the lines, left, and right of the line. For tough materials, you can go down the whole depth in multiple steps. By setting the approach and retract angle as well as distance to control how the tool would approach and exit the groove lines. Let's move on to contour operation. I'm selecting operation, contour, and assigning a tool first. This operation moves the tool inside or outside the lines forming the polygon, letting the tool perimeter barely touching the lines. Available options are obviously outside or inside, as well as not so obvious ones related to the rotation direction of the spindle, like climb, conventional, and mixed. As an example, sizing operation can be outside contour with mixed cut. Let's assign a larger tool. As you can see, the tool path moved away from the rectangle. For tough materials, you might want to go down the whole depth in multiple steps as well. Or you might need to soften the corners. The next operation is the multi-drill. It's like the drill operation we visited before, however way smarter as the following. It checks whether the geometry is a hole first. Our object is not a hole, therefore it won't create a toolpath. Nevertheless, I would like to emphasize that this checkbox allows adekoCAM to check if there are multiple holes suitable for concurrent drilling in case the machine is capable of drilling multiple holes at once. It groups the suitable holes, if any, and finally performs the action with highest possible efficiency. If the machine has a boring head, this operation saves quite a significant time during manufacturing. Moving on to Smart Cut, which is a very important operation for sizing, as it forces the tool to pass only once wherever possible to shorten the final tool path. It is meaningless in our example as there's only one part. It also requires the tool diameter to be equal to the nesting gap. This is not the case, so we see the error sign here. I'll import 20 more parts and use the operation on sizing layer to demonstrate the difference between Smart Cut and a conventional sizing operation. Selecting contour outside and mix cut as the conventional method. Calculating the toolpath and see that all the parts are cut individually and these edges are passed by multiple times as they are shared in between adjacent parts, even though it is not necessary for a large percentage of materials. If on the other hand we choose Smart Cut and select a tool with a diameter equivalent to the nesting gap, as it is the only requirement for Smart Cut, then the cutting lasts much shorter as the shared edges are passed only once. This saves significant amount of time in sizing. Moving on the next operation, but before, we need to disable the panel layer and enable the other layer on which our rectangle sits, because we will be working on the rectangle but not on the sizing layer. Our next operation is Sunken Frame. This operation moves the tool in 3D and creates a sharp corner frame, and as you might expect, it requires a V-shaped tool to be selected. It also takes depth as a parameter, as the tool will be moving in the Z-axis too. Edge and corner options let us set a margin from the edges, as well as when and how much to slow down the tool for better results in case needed. The next one is the pocket operation, which is used to carve pockets out within a rectangle as well as circles. Step over ratio controls the step size in every cycle. Depending on the diameter of the selected tool and this option, a very fine-tuned pocket operation becomes available. We can use this operation for other purposes as well. As an example, let's assume we have a large hole for which we do not have a tool, but many other tools with smaller diameters. In this case, the options are either to wait for the purchase of the tool with the right diameter or to use a smaller tool instead. Using a smaller tool and pocket operation would make the manufacturing process a bit longer for these geometric features, of course, but this flexibility would pay off considering individual projects. In this video, we show some selected adekoCAM operations. These operations tend to increase in time, as well as their settings get more sophisticated as a result of continuous development. For ultimate flexibility, use the toolpath creation commands from the adekoCAM math library in conjunction with these operations. Thanks for your attention.